Good day, guys. Hope all is well. Okay, today we're explaining study unit 9, STTN122, STTF122, and STTN121, chapter 9, the point and interval estimation. I think there's a video on my YouTube channel where I was explaining the point and interval estimation. I think the module was STTN121. So this one will be for STTF122 and STTN122. I'm going to share my screen. This is the one. Okay, let me just do this and put this here. Okay, so with the point and interval estimation, it's very important to make sure that you understand the definitions of a statistical inference. It's when you make use of a sample data so that you can gain information. Remember that information regarding what the population and the parameter, the statistic we talked about it there under chapter 1 and also the statistic. Okay, so under this point and interval estimation, the easiest chapter. This is where you must make sure that you get full marks with this chapter. Easiest chapter, trust me. So with this one here, you will be dealing with the sample mean. You've been doing the sample mean, I think from chapter 4. Yeah, from 4, 5, and so on. You also did the standard deviation. And now in this case, we're going to talk about the estimates of the unknown population mean and the population standard deviation. It's going to see. So one, the point estimation is when we're talking about, it's when the population parameter is estimated by what? The keyword is the single number. The single number calculated from where? From the sample data for the point estimation. The interval, can you just do this? The interval estimation, this one lies between the two values. So this is when you're going to deal with the two values. The other one's going to be the upper value. The other one's going to be the lower. You will see like when we do the interval estimation. Yeah, then, yeah, like that. So they call it the confidence interval, where they will say the confidence interval for 95%, 90%, 99%. Okay. All right, starting with this one. For the population mean, the point estimator for population mean, for this population mean here, it's x bar is equal to, you know this formula from chapter 4. To find the mean, you know that you can add all your data set values, you divide them by the number of observation to get the mean. Or you can use the method in the calculator. I think we've given you guys the method on how to use it to punch those values on the calculator to get the mean and to get the standard deviation. This is the point estimator for the mean. Now, the point estimator for population variance is this one. The best method to deal with this one here, what you're going to do, since it's multiple choice, if you're given a data set and then they say calculate the point estimator for the population variance, what you're going to do, you're going to find the standard deviation. I believe most of you guys, you know how to find the standard deviation using the calculator. You punch all your values on the calculator using the method. You find the standard deviation. After finding the standard deviation, if let's say, for example, the standard deviation for EG, let's say, for example, the standard deviation, the value was maybe 4.221, 4.321, like this. Then the variance in this case, the variance will be what? Will be 4.321, close bracket, and then you put to the power 2. So I mean, the minute you put to the power 2, yeah, to the power 2, then now you're calculating the variance. You see? you put to the power 2 here, like this. This is when you'll be calculating the variance. So there's no need for you to punch all to use this formula because it's multiple choice. You can just do it like this. Yeah, that's how you get the point estimator for the population variance. Now, the point estimator for the population proportion, we use this formula, the P cap. The P cap is equal to X divided by N. I will explain how to see how do you see the value of X and also the value of N. You know that the value of N is the random sample or the sample size. Yeah, for the population proportion, which is pi. When the point estimator for the population proportion, you use this formula, right? It's okay. This is the information that you'll be given, something like this. So what they're going to do, this is the data that I was talking about. They give you this data. They say calculate the point estimator for the population mean. Use this method. But since you guys, you know the method of using a calculator, you can get the mean on the calculator like this. Then for the variance, like I said, you're going to find the standard deviation after you square it like this. You square that standard deviation like this, you see, to the power 2. Then you get the variance. That's how you do it. So then the other one, with the one of the population proportion, because its P cap is equal to X over N. If you are given a statement where they say that in the population which contain more than 2% salt per unit, if they say more than 2%, under, you see here, more than 2%, yes. More than 2%, yes. More than 2%, yes. Because they're above 2%. They're above 2%. More than 2%, yes. More than 2%, yes. More than 2%, yes. So when you count all of them, it's 1, 2, 3, 4, 5, 6. So 6 out of 10. Because now this is the whole thing, all of them, it's 10. So it's going to be 6 out of 10, which is 0.6. That's how you're going to get the proportion. But the question that you'll be given, you'll see how they ask the question that are based on the proportions, the population proportions. Yeah. And again, it's very important to know the properties of the point estimator. The point estimator. You need to know that it's under it is biased, reliable, efficient, and consistent. 4 of them. Now, let's talk about this. This is very, very important. If it happens that they give you a statement, on that statement they say calculate the standard error. Calculate the standard error of the mean. This is the formula that you are going to use, which is the standard deviation. You will be given the standard deviation divided by square root of n. You will also be given the square root of n, which is the random sample. So it's easy to calculate the standard error. This is the formula that we are going to use. Great. And then now here under the interval estimation, because now we did the point estimation. You saw the formula that you're going to use under the point estimation. Calculate the point estimator for population mean, calculate the point estimator for the population proportion, calculate the point estimator for the variance, calculate the point estimator for the population standard deviation. You know which formula to use. Here, under the interval estimation, with students who are doing STTN122 and STTF122, for them, the formula's straightforward because you just need to know that the confidence interval of the 90%, you're going to use 1,64. Just need to claim it like this. The confidence interval of 95%, it's 1,96. The confidence interval of 99% is 2.58, like this. If they say calculate or determine or calculate the confidence interval of 90%, you're going to use 1,64. The confidence interval for 95%, you're going to use 1,96. The confidence interval for 99%, you're going to use 2.2,58. Let's see the formula. 1. Under the interval estimation, we have the first formula. We use it when we are given the X bar as the sample mean. We're also given the sample standard deviation. We're also given the N, which is the random sample. You see this whole part here, this Z alpha divided by 2. If for e.g. they say calculate the confidence interval for 95%, here you're going to put 1,96 here. Obviously, you will be given X bar, you substitute the value here. On this part, you put 1.96 multiply by, you'll be given the standard deviation, you'll be given N. You go to this side, you substitute the sample mean, plus this whole part again, Z alpha divided by 2. If they say 95%, you're going to put 1.96 multiply by the standard deviation you'll be given over square root of the n, which will be given. You're going to get two answers. The first answer for this one and also this one. That's the reason why they say that it lies between the two values, the interval values. That's what you call the interval, the confidence interval, the interval estimation. The first formula will be given there on the formula sheet. That's the first one. You see on this one, you will be, now you see, we are given the sample mean, the sample n, 55. The sample mean here it is. The standard deviation it is. Now they are telling you 95%. Remember I said with 95%, you use 1.96 confidence interval. But if they say 99%, you use 2.58. If they say 90%, you use 1.64. That's how you do it. Then this is the method they used. You substitute, you see, the value of the x bar. Remember I said this whole thing here, alpha divided by 2, it's 1.96 because they said 95%. Then multiply by the standard deviation over square root of n, we are given. You do the same thing here, but here you're going to use plus because here they used minus because it's 2, the upper and the lower one. You do it like that. So you get the interval. This is the interval here. Your interval estimation values. That's how you do it. Interesting. Now, we saw the first formula. It was for the confidence interval for the population mean. Under the interval estimation, we have two formulas. The confidence interval for the population mean and the confidence interval for the population proportion. You see the reason why I was saying that this is the easiest chapter. You see with this one, when we're talking about the point estimation, if this you saw the formula of the point estimator for the population proportion, we say that the p cap is equal to x over n. So here in this case, what you're going to do, where you see p cap, just try to recall the formula. P cap is equal to x over n. You will be given x. I'll show you how to see the value of x. You'll also be given the n. You just substitute. Same thing, the z alpha divided by 2, this part here. If they say 95%, you put 1.96. Same thing here, 95%, you put 1.96. If they say 95%, 1.96, 99%, 2.58, 90%, you put 1.64. That's how you do it. Then you substitute all your values. Now you know how to go with the p cap, x divided by n. Let's look at the question. This is the example. Let's check, how do you see the value of x? How do you see the value of n? Let's check. Now, they say that the National Safety Council would like to estimate the proportion. You see that you're dealing with the proportion, the confidence interval for the population proportion of vehicle accidents that are pedestrian related in a sample of 220. This is n. This is n. Vehicles in Johannesburg. It is found. You see, it is found that 30 of them. The minute that it is found that this number, which is 30, this is where you're going to find x. This will be the value of x. Now you can calculate the p cap. P cap is equal to x over n. 30 divided by 128. Now they say calculate the 19%. Remember I said 19% is what? 2.58. 90%, 1.64. 95%, 1.96. Do the math calculation, get the answer. This is the method they used. You see, the p cap here it is 30 divided by 128. Got this answer? You do it like this. You substitute. P cap, you can use that formula, the one that I showed you. It's the same thing, this formula. You use this one. Now you know the p cap. Where you see this part, you put 1, because they said 99%, you put 2.58. You do the same thing here, you get the answer. That's how you do it. Yeah. Then what's the other one? Again, you saw there was this formula where I said it is a standard error of the population mean. We also have a standard error of the population proportion, which is this whole part here. This whole part, it is the standard error of the population proportion. If it happens that they say calculate the standard error of the population proportion, you're going to use this formula. You saw that with that one, if they say calculate the standard error of the population mean, use this one. You say that the standard deviation over square root of n. This is the formula for the standard error of the population mean. This is the formula for the standard error of the population proportion. So yeah, that's how you do it. Think now, rest it's the examples, just repetition. You see, yeah. So now let's look at I think it's test 4 2024. Test 3, yeah, test 3. I'll only focus on the questions that are based on the interval, the point and interval estimation. The point and interval estimation, which it's gonna start from this one here. From this one. So what I'm going to do, they say now, let's look at the question. Use the following information to answer question 11 to 12. Interesting. Already you can see the answer, but the important thing is for you to know how they got those answers. Consider a survey conducted on a sample of 50. N is equal to 50. You can all see that. N is equal to 50. N of STTN121 students to ascertain the proportion of students who prefer tea over coffee. The findings are as follows. The number of the students who prefer coffee is 20 of them. The number of students who prefer tea, 30. So 20 plus 30, you will get the sample of 50. What is the point estimate for the proportion of students who prefer tea, who prefer what? Tea. Who prefer tea over coffee. They prefer what? They prefer tea here. They prefer tea over coffee. So it's what? The P cap. Remember, the P cap, the point estimator, the P cap, because now we're dealing with the proportions. The P cap, which is equal to, you know that it's X divided by N. The question is, we know that the N will divide by 50 here, 50. But the thing is, what is the value of X? They said the of students who prefer T. The number of students who prefer T, it's going to be 30 of them. Because they said T over coffee. T over coffee. So it's 30 divided by 50, which is 0.6. Then you're done. Now, here they say, so now you know that, let's look at the question again. Calculate the 99% confidence interval. Remember what I said? 99% confidence. What is the answer? 2.58. 2.58. Let's write it here. If they say 90%, you use what? 1.64. If they say 95%, you use what? Use what? 1.96. If they say 99%, use what? 2.58. Here it is. So here in this case, they said 99%, we're going to use 2.58. Which formula are we going to use? The one that starts with P cap. So it's something like this. The P cap, let's go back so I can show you the formula. This is the formula here. We're going to use this formula here. P cap minus the Z, then the square root of this whole thing here. Because already we're given the P cap there. Because they said of the student who prefer tea over coffee. Still the same thing. You're still going to use the P cap of 0.6. So what you're going to do, you're going to say now 0.6 minus, what is that? The Z alpha divided by 2 under 99%. It's 2.58. 2.58 multiply by, then now you have to do a square root. You have to do a square root. It was the square root of what? The square root of, let me just erase this. The square root. The square root of what? It was the P. What is the P? The P is 0.6 into 1 minus 0.6. Then we have to divide the whole thing by what? We have to divide this whole thing by N. And what is the N? It's 50. And then now it continues like this. Then you move to the positive one. You do the same thing. Let me write it here. You do the same thing. 0.6 plus 2.58. Let's write it down. Plus 2.58 multiplied by, we put the square root there. Let's put the square root. The square root of what? The square root of 0.6, 0.6 into 1 minus 0.6. We do this, then we divide the whole thing by what? By 50, because n is equal to 50, by 50. And then we cannot close the bracket. You see now, it was something like this. Now let me cancel this one. Like this. Now, we punch this whole thing on the calculator. Let's start with the first one. 0.6 minus 2.58 multiplied by, you do a square root, 0.6 into 1 minus 0.6 divided by 50. The first one on my side, I got 0.4212, which is now it's this one. Now, since now you have the information on your data, you're just going to remove the minus. You just put plus. You remove minus, you delete minus, you put plus. And I got 0.778, which is you round it to two decimal place, you'll get 0.78. That's how you do it. Then now free 4 marks. Let's look at the other question. This is the one. Use the following information to answer question 13 to 15. Interesting. Suppose we wish to estimate the average amount of time customers spend on a website each day. We take a random sample of 35. This is n. And find the following. The sample mean we're given 35. The sample standard deviation 1.8. Now let's check. What is the point estimate for the population variance? No. Are you given the data set? No. What is the point estimate of the population variance? Interesting. Remember when I was explaining study unit 9 or chapter 9, I said that if it happens that they give you a data set and you are required to calculate the point estimate for the population variance, what do? You punch the values on a calculator, you find the standard deviation. After finding the standard deviation, what do? You do this. You say now that standard deviation, you do this. Standard deviation, you set to the power 2. By using this method, you are finding what you call a variance, the population variance. So here in this case, you don't have to do the same thing. The standard deviation were given 1.8. You close the bracket, you put to the power 2. Then you get the answer. You just do this on a calculator, 1.8. Then you get 3.24. Then you are done. Here it is. Free 2 marks again, 246. Another one. Calculate the value of the estimated standard error of the average, standard error of the mean. Which one are you going to use? Standard deviation over square root of n. And what is the standard deviation we're given? It was 1.8. 1.8. So now it's going to be 1.8 divided by the square root of what? What is the value of n we're given there? It's 35. So divide by the square root of 35. Then now the standard error is 1.8 over square root of 35. Then you get 0.30. Here it is. Interesting. Now, they want us now to calculate the 90% confidence interval. Remember, here, the information, 90% confidence interval, use 1.64. 95% use 1.96. 99% use 2.58. So on that one, they said 90%. So we're going to use 1.64. So here in this case, I just use this information here. Already we know our mean. So what we're going to do, we put this. We just do this. Interesting. So here, what is the value of the mean? In this case, the mean is 35. So it's going to be this side, we're going to put 35 minus, what is that thing? Because they said 90%, 1.64 multiplied by, now it was what? It was, remember the formula. This is the formula. Where is it? This is the formula. Remember this formula. Where is it? This is the formula. So I said 35 minus 1.64 multiplied by, I'm going to put the standard deviation over square root of n. And already there's no need for me to calculate this one because I got it there on the previous question. I just want to substitute that value. Multiply by what? I got it here. It was 0.30 because remember, according to the formula. So what I'm going to do, I'm just going to put 0.30. Now I'm done with this part. I move to the other one. Now it's 35 plus 1.64 multiplied by 0.30. Then now we can use this. You do it like this. On my side, let's start with the first one. 35 minus 1.64 multiplied by 0.30. which the answer, it's 34.50. Here it is. Now since you still have the data on your calculator, you delete that negative, that minus, and then you put the plus sign there, and then you get the answer, which is 35.492. You round it to two decimal place, and then you will get 35.50. It is. You see, interesting. So this chapter is interesting. Yeah. Please don't forget to like and subscribe to my YouTube channel so that you can see more of my videos. Yeah, and I really appreciate it. Thank you.